Okay, this is the first of a couple of videos I'm going to do on trig equations. The first one is to look at some easier types. We're going to ease our way into it and not make it too complex, because if we can master these ones, then the more difficult ones should be accessible to you. Okay, so what are trig equations? Well, we know what an equation is. We've got to solve for x or theta, whatever the case may be, and they involve trig. So they're like equations we've always done, but they involve sine, cos and tan. So we'll start with this one. Cosine x equals negative root 2 on 2. Now, there's different ways of doing this, and if you've got a calculator, there's you can even graph them, or you can solve them on your calculator quite easily. But we'll deal with that later on. We're going to go first of all with a situation where we haven't got a calculator. Alright, so I'm going to change coloured pen here for a moment to red, because first step is to really find what's called the basic angle. Okay, what's the basic angle? Well, if I just circle that root 2 over 2, and I'm ignoring the negative for the moment, the negative is very relevant to this question, don't get me wrong, but I'm just focusing for the moment on root 2 on 2. And then I need to say to myself, well, what is an angle that has a cosine value of root 2 on 2. Now you may know, or if you don't know, you can look up the table on page 300 in your text or the information sheet for the exam, and you can see that an angle that has a cosine of root 2 on 2 is pi on 4, and we're going to use radians here. I should have mentioned that. So basic angle equals pi on 4. So we'll start with that. Okay, now we're looking at, well, what quadrant is this angle in? Because our cosine value is negative. Okay, what quadrants is cosine negative? Well, they're all positive in the first quadrant, so it's not negative there. Sine is positive, so it's negative in the second quadrant. It's negative in the third quadrant because tan is positive. And it's positive in the fourth quadrant. So we're looking at the quadrant we're after. We're looking at second and third quadrant. That's where our solutions are going to lie. Okay, and just point out, we're looking for solutions here between 0 and 2 pi. So just one full revolution here is where we're looking for our answers. And we're looking for answers in the second, third quadrant. Why? Because our cosine value is negative. So two steps there on this first slide. We look for the angle that has a cosine value of root 2 on 2. We're ignoring the negative when we look at that. Okay, it's not relevant. Then we look at the negative and we say, okay, cosine is negative in second and third quadrant, so that's where my solutions lie. We'll continue on the next slide. Just back to these little rules the other day that we developed from the unit circle. Okay, so we can see there cosine value is negative in second and third quadrant. Okay, remember our cosine value was negative. It was negative root 2 on 2. So our solutions lie in those quadrants. So once we've found the basic angle, the finish is quite straightforward here. Because what we're looking for are values of x. X is going to be two values. It's going to be pi, minus our basic angle. Okay, so pi minus our basic angle, coming from here. Also, third quadrant, pi plus our basic angle. Alright, so there are our two solutions. Now pi is the same as 4 pi on 4. If we take pi on 4 away from it, it's 3 pi on 4. And pi plus pi on 4 is 5 pi on 4. So there's our two solutions to our equation. Let's review. Our equation was cosine x, and sometimes these questions will have x or theta, this one's got x, equals negative root 2 on 2. We ignore the negative. Our basic angle that has a cosine value of root 2 on 2 is pi on 4. We then factor in the negative, and we know that the answers are going to lie in the second and third quadrant, because that is where cosine is negative. Then, what do we do with our basic angle? Well, second quadrant, we take it away from pi. Third quadrant, we add it to pi, evaluate those two answers, and we've solved our equation. X is 3 pi on 4 or 5 pi on 4. Okay, second example now of a equation here, a trig equation. And I'm going to use theta this time instead of x. So we need to get used to the fact that it could be alpha or beta or some Greek letter, but it's most likely going to be theta or x as they are unknown. So I'm using theta this time, but it's the same principles will occur. Okay, so we've got, actually, I'm just going to write this question out again because I just realised I made a mistake. So just modify that just a little bit. That's alright. Okay. That's still a 3, so just make that clear. Actually, I might just rub that out too and make sure that's obviously a 3. There we go. So 2 sine 2 theta equals negative root 3. So the first step here is we're going to divide through by 2. So before we embark upon these trig equations, always look for those sort of things first before we go any further. So there we go. Sine 2 theta equals negative root 3 on 2. Okay, so now we're going to look for our basic angle. But before that, what I'm going to do here is I'm going to adjust the domain, because the domain at the start, we're looking for basically values of theta between 0 and 2 pi. Okay, that's what we're looking for. That's what we're asked to look for. Now, I'm going to explain this more fully at the end, so just stay with me for the moment. But when you've got something involving 2 theta, okay, it effectively becomes this. We're looking for values between 0 and 4 pi. Now notice I've changed that to 2 theta. So the question asked us to get that domain. I've adjusted the domain because we're looking here initially for 2 theta. Okay, I've doubled the domain. So how does this work? If it's 2 theta, you double the domain. If it's 3 theta, you triple the domain. If it's a half theta, you halve the domain. So depending on what that is, the factor there, or the number in front of the coefficient in front of theta, you change the domain. Alright, so just repeating, because it's 2 theta, I've now doubled the domain from 2 pi to 4 pi. Alright, and that'll make more sense at the end of the problem. Alright, same as last time. We're now looking for basic angle. And we're looking for an angle. I'm ignoring the negative. Okay, I'm just looking, changing pen colour here. Just looking for root 3 on 2 in my table or in my head, if I've committed this to memory. And the basic angle here is pi on 3. So I'll write that down. Back to the black pen. That's pi on 3. Alright, now it's negative. Negative root 3 on 2. So we're looking for quadrants where sine is negative. And sine is negative in third and fourth quadrants. So sine is negative in what I say? Third and fourth quadrants. Okay. Now, if I'll just copy this over to the next slide. In fact, I might. No, what I might do first is just copy out our table again, because we'll need that in just a moment. So put that down in the bottom corner here, and just go back and copy our problem so far over to the next slide, and we'll see where we're at here. Okay, so that's where we got to. Just rub that out. Sorry. There we go. Alright, now we're in third and fourth quadrants. Right, so we're looking at third and fourth quadrants. There they are. So in third quadrant, okay, we're looking at pi plus theta. In the fourth quadrant, we're looking at 2 pi minus theta. So 2 theta equals pi plus our basic angle, and fourth quadrant 2 pi minus our basic angle. Now remembering that our domain here that we're looking at between 0 and 4 pi. I've doubled the domain, which was originally 2 pi, for reasons you'll see in a moment. So I've got to go around a second time. Okay, so remember, they're the solutions between 0 and 2 pi. If I just draw my circle, and we go around from 0 right round to 2 pi. Now I need to go around again. So to get the other two solutions, they're going to be 2 pi, that's going around once, plus pi on 3. And the other solution is 2 pi plus 2 pi minus pi on 3. Now, if you look carefully there, you can see that I've just added that solution to 2 pi and that solution to 2 pi to signify that we're going around a second time. Okay, so let's look at our next step. Alright, now back to black pen, 2 theta equals pi plus pi on 3 is 4 pi on 3. 2 pi minus pi on 3 is 6 pi on 3 minus pi on 3 is 5 pi on 3. Next one. Now, we're basically adding 2 pi to our first result. Now 2 pi, remember, is 6 pi on 3. Okay, so that's going to be 6 pi on 3 plus 4 pi on 3 is 10 pi on 3. Last result here, once again we're adding 2 pi to our second result. 6 pi on 3 plus 5 pi on 3 is 11 pi on 3. Alright, now we've clearly got some results there. If we go back to our original domain, okay, which was 0 to 2 pi. Okay, just remember that. Clearly here we've got results that are outside 2 pi, those last two. But why did we double our domain? Because now our last step is to divide, because we've got 2 theta and we're trying to find theta, is divide through by 2. So we get 4 pi on 6. Okay, if you divide, we might just go back a step there. If we get 4 pi on 3 divided by 2, okay, there's effectively 4 pi on 3 divided by 2 on 1. If we are dividing fractions, we invert and multiply, so it's times 1 on 2, and that's 4 pi on 6. Now the shortcut is, of course, if you're dividing through by 2, you multiply the denominator by 2, so that's going to be 5 pi on 6, 10 pi on 6, and 11 pi on 6. Cancelling down, because some of these can be cancelled down here. That's 2 pi on 3. That one can't, so it stays as 5 pi on 6. 10 pi on 6 comes down to 5 pi on 3. And 11 pi on 6 stays as is. So there, ladies and gentlemen, are our 4 solutions. 2 pi on 3, 5 pi on 6, 5 pi on 3, 11 pi on 6. Let's do a review. Okay, so there was our original equation, divided through by 2 in the first step. Found the basic angle by ignoring the negative. What angle has a sine value of root 3 on 2? It's pi on 3. Now it is negative. Sine is negative according to the cast diagram in the third and fourth quadrants. Okay, so if it's in the third and fourth quadrants, according to our rules here, it's pi plus pi on 3 for the third quadrant, 2 pi minus pi on 3 for the fourth quadrant. Because we're dealing with 2 theta, we doubled our domain, so we went to 4 pi, which is going around twice. So they're the solutions for the first revolution. These two are the solutions for the second revolution. Okay, you've gone around 2 pi and you're going around a second time. Okay, evaluate those, you get those 4 results. And then divide through by 2. And the dividing through by 2 brings them all back within, if you look at our solutions there, they're all within 0 to 2 pi, which was our original domain. So when we're dealing with 2 theta, we double the domain, knowing that when we halve it again, when we divide through by 2, it brings our answers back into the domain that we need. Okay, the third and final example for this video is this one, sine 3x equals cosine 3x. Now, talk a lot about light bulb moments, okay, in class, and a big light bulb moment here. Just trying to draw a light bulb. Flash, 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 flash. Okay, big light bulb moment is when you get sine on one side and cosine on the other. Okay, as soon as you see that, the light bulb is, this is a tan equation. Okay, sine on one side, cosine on the other, it's a tan equation. Alright, how do we make it a tan equation? We divide both sides by cosine. So in other words, sine 3x gets divided by cosine 3x, and so does cosine 3x. That preserves our equation. Remember, if you divide an equation by the same thing on both sides, it's still a valid equation. It still exists. Now remember, we had a little result at the start of Trig that we investigated, and that was that sine x over cos x equaled tan x. So sine 3x over cos 3x is equal to tan 3x. Cos 3x over cos 3x equals 1. So this becomes tan 3x equals 1, our equation. So we basically start now. That little conversion there is to get it in the form of a tan equation. But remember, a big trap is that you don't recognise that and you panic and think, well, how am I going to work this out? Just remember, sine on one side, cosine on the other, it's going to be tan. How do you get it into tan? You divide by the cosine expression on both sides. Alright, so effectively, as I said, that's our question. And we start with the basic angle. Well, by the way, I should have mentioned that I'll just go back a step because I didn't write in the question. The domain for the question, once again, was 0, and we're using the x again, used theta in the last question, but back to x again, is 0 to 2 pi. Each of these trig equations you'll be given a domain. In other words, find the solutions between these two values. You're not finding unlimited solutions, you're given a restricted domain to find them in. Okay, so effectively, as I said, tan 3x equals 1, and here's the domain we're looking at. Alright, now we can adjust that domain. Remember I said that if it's 3x or 3 theta, we triple that other value there, which is 2 pi to 6 pi. Okay, in the previous example we went from to 2, when it was 2 theta, we went to 4 pi. Okay, this time because we've got a 3x, we triple the 2 pi to get 6 pi. So that's our domain we're working with for 3x. Alright, back to the basic angle. Okay, looking at the table, or from memory, the angle that has a tan value of 1 is pi on 4. That's our basic angle. Our tan value is a positive 1. So in our cast diagram, where is tan positive? It's positive in the first and fourth quadrants. Okay, it's the first time we've had first quadrant. Okay, so when we get this situation, 3x is going to equal our first quadrant, which is just pi on 4. All right, that's our first quadrant value, and our third quadrant value is pi plus pi on 4. But we've got a couple of other values to look at. Let's just get rid of our cast diagram for a second, because remember, because we're going to 6 pi, here we're going around 3 times. Okay, 3 times. Remember our unit circle here, 0 to 2 pi, that's once. Second time is 4 pi. A third time is 6 pi. So effectively with those two solutions, pi on 4 and pi plus pi on 4, that's the first time round. Second time round, okay, we've gone round once, plus our first solution. We've gone round once, plus our second solution. Continue down here. We've gone round twice, so we've gone round 4 pi now, plus our first solution. We've gone round twice, plus our second solution. So you can see with those two there, that's the first rotation round to 2 pi, then they feature again. Okay, second time round, they feature again. Third time round. Okay, let's tidy this up. We'll go to the next slide. Okay, so 3x equals. This is where our fraction work is really important, guys. Pi on 4. Pi plus pi on 4 is 5 pi on 4. Now, the shortcut here is to add 2 pi to our two answers so far, and then 4 pi to our two answers so far. And 2 pi, remember, is 8 pi on 4. So if I add 8 pi on 4 to the first guy, I get 9 pi on 4. If I add 8 pi on 4 to the second guy, I get 13 pi on 4. Oops. 13 pi on 4. Okay, third time round, okay, is going to be 4 pi plus our first two answers. 4 pi is 16 pi on 4. So 16 pi on 4, oops, plus our first answer will be 17 pi on 4. So that's 16 plus 1. 16 pi on 4 plus our second answer is 16 plus 5 is 21 pi on 4. Now, why do we go out to 6 pi? Because now we're dividing through by 3, which brings us back to 2 pi. So I divide all of these now by 3. Shortcut is that you multiply the denominator by 3. So that's going to be pi on 12, 5 pi on 12, 9 pi on 12, 13 pi on 12, 17 pi on 12, and 21 pi on 12. Still got to cancel down some of these answers a little bit further. So there they are. Equals. First two are okay. 5 pi on 12. 9 pi on 12 9 pi on 12 cancel down. Divide both by 3, we get 3 pi on 4. 13 pi on 12. 17 pi on 12. And the last one, we can divide 3 into both of those at 7 pi on 4. There's our answer. Let's review. Okay. Sine equals cos, light bulb moment is tan. How to create tan? We divide both sides by cos 3x. We know from earlier on that sine divided by cos is tan. Cos 3x divided by cos 3x is 1. That effectively is our question. Our original domain is 2 pi. Because we're dealing with 3x, we lengthen that out to 6 pi because we know that when we divide through by 3 at the end, it'll bring us back to that domain. Basic angle is pi on 4, we got that from the table. Tan's positive, which occurs in first and third quadrant. Because it's 6 pi, we go around once by adding 2 pi to our first two solutions. We go around a second time by adding 4 pi to our first two solutions. Right, then we've got some number crunching, bit of fraction work, and we get our 6 solutions last step is divide, or second last step is to divide through by 3, and eventually cancel down the 2 there that can be cancelled down further. So there's an introduction to some easier trig equations. I'll just pause here for a moment and I'll write down some questions to do. Okay, I'd like you to have a go at question 5, question 7, F and G. Also questions 8, A through to D. Just watching that one, because it says, if you read carefully, calculate the sum of the solutions. Okay, so if I had to calculate the sum of those solutions, basically I would have added them all together. Okay, that one plus 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 that one. So it's just done normally, but you add the solutions together at the end. So just watching A to D, you might get confused by the answers, but that's the extra step. You've actually got to add them together. So question 5 is 4 problems. Question 7 is a couple of problems there. And then question 8, as I said, A through to D. See how you go with those, and we'll go into some more complex ones in the next video. That's all for now.